Hello everyone, my name is Nicoya, and this is the Roland JP-8000. Now, most people know this as the trance machine. Basically, it introduced the rather famous super saw sound, and it is also well known for eating capacitors because this is basically a mid-90s, late 90s computer, and if you know anything about retro computing and everything, that is a great time to have a lot of surface mount electrolytics dry out and go crispy and dead. And so we are going to go into this and we are going to replace those capacitors because this synth was making some popping noises. You'll also often find that it'll have like very low or distorted output, and that is a classic sign of the capacitors going dead. So we are going to need a specialty tool for this operation, and that is a pillow because we have to flip this over on the back, and we have all these knobs, and especially this control stick that we do not want to break off. So I'm going to get this flipped over and get the screws out of it, and there's like 900 of them, so let's get to that. So upon seeing all these screws on the bottom here, you might wonder which of them you have to take out, and the answer is yes. Alright, let's see, did I forget any? Oh, we are good. Oop, don't want to bump the camera. Alright, we are in like sin. So, the majority of the capacitors that we're concerned about are under this plate on the main board. This has all of the sort of microprocessing bits in it. But while we're in here, we're also going to replace the ones on this board because, quite frankly, they're right there. So why not? It is, I believe, fairly rare for these to actually cause a problem, but, you know, the entire replacement kit that I will have a link in the description to that way is around $10, so you're not wasting a lot of money here. And you got all these screws out, you got your soldering iron warmed up, you might as well. So, the next specialty tool we're going to need is actually a pick to undo these connectors here. Alright, so these two cables here, they go into a sort of fancy kind of connector which has a retaining clip on it. So if you lift off that retaining clip, they just slide right out. If you don't lift up the retaining clip, it ain't going nowhere. So just go under there, lift it up, and it comes right out. And actually, while we're in here, we'll also grab this one. Because we're going to want to pull this board, and in fact this board, entirely out. So, why don't we grab this one as well. There we go. And we'll have to remove this grounding cable. I'll remove it from this side. And grab my regular screwdriver for this. So, I'm going to remove grounding screw from here. So that will free up this board, I believe. I don't think there's anything else connected on the bottom or anything. So, there are 3 screws in the back here. 2 on the MIDI ports. And 1 plain mounting screw. And that board is now completely out. And I'm going to put these screws back in here temporarily so I don't forget which ones go where. So that's board number one. Most of these are just audio DC blocking capacitors. They don't usually cause a problem, but there are, I think one of these ones is actually power supply filter, and so they can go dead after a while. So we got that cable out. We'll take the grounding lug off of here. So that's that. This will flip out of the way. Now we have connectors here. So these are for the front panels. So the connector closer to the power supply is closer to the keyboard. So remember that. And these just slide out. And the one over here is in sort of this corner. You can kind of picture that. So this one is in the rear connector. They're actually different lengths too, it looks like. So yeah, you shouldn't be able to screw that up. This one's like 2 pins longer. But then again, I don't know you. I don't know what you can screw up. Anyway, these ones are fairly self-explanatory. The keyboard matrix. And then this one, which goes down to the display, it looks like. So, I got one more connector here, which I'm going to grab with a pick. If I can. Let me see, can I just grab it like that? I don't really want to grab it like that. Okay. Let me see if I can grab that with me pliers. There we go. Alright, I can actually pull this out of the ferrite, I guess. Clear that out of the way. You don't actually have to do that. You can just flop this whole panel over. Lost one of the screws. Set that aside. Grab that screw I dropped. And we continue with the next layer. So, there's a couple more screws to remove the actual board. Oh, and we're also going to replace this battery while we're in here because, you know, we're in here this far. We might as well replace it, and chances are this has never been replaced. Alright, so these ones have no washer on them, whereas the other ones had a washer, so let's remember that. These ones are also threaded into plastic studs instead of into these metal brackets. So that's good to remember. And let's see, are we free? Nope. One more. And now we are out. And we can take off this shielding cardboard. There we go. Alright, so I'm going to show you a close-up of this, but our two enemy capacitors here are this 100 microfarad and this 22 microfarad. So this 22 here, it is responsible for the muting circuit, and so when the synthesizer powers up, this capacitor slowly charges, which activates these transistors, and that in turn activates transistors over here, which would normally pull the outputs down to ground. Actually, probably down to minus whatever 12 volts, but you get the point. It blocks the output signal until the power comes up, and then it slowly lets it back out, so you don't get that really big click or thump or whatever when you turn on the synthesizer. This 100 microfarad cap is basically the primary filter capacitor, the bulk filter capacitor for this entire board, and it has spewed its guts all over the PCB. And that's actually why I'm sort of skipping forward and doing this synthesizer first, because this is actually my latest acquisition. I got a bunch of others sort of stacked up, quote unquote, before this, but if we leave this electrolyte on the board, it will absolutely eat through traces and eat legs off of integrated circuits. Like, it could eat legs off of this thing and the whole board would be dead, the whole synthesizer would be dead. You can't get replacements, as far as I know, for this board. So yeah, you really do not want to like just throw this into a closet and forget about it for 3 years because you're frustrated that it was making noises or that the output was distorted or whatever. You want to fix this as soon as it goes bad. In fact, you want to fix it before it goes bad. If it is, you know, never been done on your synth, do this right now, whether it's malfunctioning or not. Like, absolutely 100% do it. So I need to make some space, get the rest of the synthesizer moved out of the way so we can deal with replacing these capacitors. Okie dokie, so we are all cleaned up now, and I just noticed that my camera was syncing on the last shot, so my apologies if you got a slightly seasick feeling from that. Anyway, we're going to work on the jack board first because it's easy. Nice through-hole components, lots of room, versus, you know, the crowded mess of surface mount components on this board. So most of these on our jack board are going to be 10 microfarad capacitors, which are these ones here. And so we're going to do these ones last so that we can just replace the remainder of them without thinking too hard about it. But the ones we need to care about is we have one 100 microfarad capacitor, which is C6, and then three 47 microfarad capacitors, which is C5, C18, and C19. So C18, C19, and then what does it say? C5 is this one right here. So I'm going to warm up my desoldering iron, and we will pop these ones out first and then replace the rest of them. Alright, so we'll start with C6 here, which is the 100 microfarad, and it is right between a transistor and a diode ahead of this chip. And so if we flip this over, we have the chip, the diode, the transistor, and that'll be the capacitor. And of course the leads are bent over, because why wouldn't they be? That didn't melt yet. Oh, this is going to be annoying, isn't it? You know, I'm going to do myself a favor. There we go. Snip one of the legs and take the other one off. Get rid of this one that's apparently glued down. There we go. Now, we can install the new one. And we'll be nice to the technician in another 30 years' time who has to replace these capacitors, and we will not fold the legs over. So as we can see, the stripe lines up with the stripe on the board, so make sure you get that in the right polarization. There's one down and about, what is it, 6, 9 to go. So let's get on with it. So next is the 47s. And again, I think I'm going to snip one of the legs of these and then use that to make my life easier. Yes. Okay, so you can see how that goes now, and I will finish up the rest of these, just the 6 more 10 microfarads in the exact same way. All right, there we go. We are done with the jack board. All of these capacitors are replaced here. And so this should give us no problem, again, for the next 30, 40 years. These are much higher quality capacitors that I replaced these with. These are like, do they say on here? I don't think so, but they're like 3,000 or 4,000 hour 105C capacitors versus these ones are probably like 1,000 hour 85C. Yeah, they're 85C capacitors. So these will last a much longer time and should give us no problem in the future. So that's cool. Now we get the fun part of taking off all these surface mount capacitors. Now, there are a variety of ways to remove and replace surface mount capacitors. If there were not these connectors like sitting right here, I would use hot air. I do have a hot air station, as you might be able to see. But since we are dealing with these meltable connectors, which are not that hard to find, but I don't want to replace them, we're instead going to be using a little bit more of a old school technique, I guess. We're going to heat up the legs one at a time and basically lift these capacitors off the board. So let's see if I can do that without completely destroying this PCB. And I want to use the... I think that might be up. Let's see. No, that's definitely up on that side. You know what, this one I think I'm going to clip. So, I take back what I said. We'll go ahead and clip that off. Now, it looks like the lead's still there, or do they come up with the thing? I think they are still there. So, we'll go ahead and wipe them out. Oh, nope, that was just the trace of the solder. So we're actually good. Or is that the lead there? That might be. Either way, we will want to clean up these pads a little bit, like that. And then, yeah, that one was sort of right against this connector. I think I can get the rest of them by heating and raising. Oh, I can smell that fishy stuff. Yeah, this is the one that was definitely leaking the most here. I'm going to grab a little extra solder to help conduct the heat into there. There we go, that's what I want to do. There we go. So now you can see what an utter mess is underneath that capacitor. But luckily, I think we are not completely dead here. So I am going to grab a little bit of alcohol to clean that off. There is a ton of corrosion on that pad, let me tell you. Let me think here. Ooh, a little bit of solder mask lifted up there. Grab a magnifier, take a closer look. All right, can you see that there? Probably not. But let me see. Oh yeah, it is ugly. But I think that the actual copper is fine. Yeah, I'm down to the copper there in a bunch of places. Grab some flux, see if that'll help. So yeah, this is exactly why you don't want to leave this alone. Because these traces, they go completely, you are in so much trouble. All right, that seems to be wetting out okay, yeah. Right. Clean off that flux. And just want to get in here and take a real close look. Oh yeah, that's fine. You got multiple connections on that side. So I'm just looking to make sure that between this pad and this area here we have good connection. This area here looks fine. This pad to here, you got, I think, a ton of, yeah, we got some good connections there. So we should be all right. And I'll give you a close-up look hopefully in that camera. So now we need to get the new capacitors back on here. So I want to start with the right bag. So this is a 100 microfarad capacitor. We're going to put this one on second. These are all the 10 micros, which you're going to have fun with. And this is the 22. So I want to install the 22 here first because we're right up against that connector. I've already melted a slight dent in it, and I don't want to be dealing with getting around the 100 microfarad capacitor to put this in. So grab a tiny bit of flux to stick this down. And now these have a little sort of plastic boat on them, and you can see that on the positive it is angled. And so you can either look for like the negative symbol on here or where the little sort of angled front is and drop it in place. Sort of like that. And see if we can get in here and actually melt that solder and make a joint. Trying to slide it to one side here a little bit so I can get in there. And of course I see that and I just push it out of the way. And I don't want it back that far. Don't want it forward that far. For goodness sakes. This is a little bit tricky. For goodness sakes. Let that cool off for a second. This is much easier when you can actually use hot air, let me tell you. like that. There we go. Now we can sneak in the front. On one side or the other. I think I should be able to get it from here. There we go. A little bit ugly, but it'll do. Now, that should hopefully be the most difficult one, and if not, I am going to go insane. So let's get this 100 microfarad in here. Put a little bit more solder on this pad. Try and scrub it in there a little bit. And again, line up the angle side with the angles and the other side with the other. And I will put a little bit of extra flux on there. I think I can actually be fine without it. Solder's a bit lumpy on this side, but we'll see what we can do. There we go. Not my most amazing work, but considering the circumstances, it'll do. Got a little bit of solder on the side of the case there, that's not great. Get a little bit of that excess out of there. I do not want that bridged. There we go. Yeah, I just accidentally bridged a bit of solder to the side of the case there. But now it is free and it will not be shorting out anything. So we're good. Those both seem secure. And now for the rest of them. So let's see how much of a pain in the ass these will be. There we go. After. Okay, so he's leaving that. Ew, that's unfortunate. So we got a lifted copper pad there. And I'm going to need to figure out how to repair that. And I tell you what, I think I'm going to go back to clipping these because I don't want to lift another pad. That could be bad news. So I'm going to grab my microscope and see what pad I screwed up. Okay, that took more concentration than I could necessarily deal with on camera, but we are back in business. I was able to bridge from the via to the neck component over there, and then that was a perfect alignment for putting the lead of that capacitor onto. And I'll show you some pictures on screen. And so now we'll get back to business. So we are going to clip the rest of these because I'm not getting too happy with that levering technique. Make sure we don't take off any neighboring parts. And yes, I know this looks horrifying, but it is actually very gentle through the PCB. Well, that one went somewhere. Make sure you're wearing your safety squints. Yep, just went halfway across the room. You know what? I think there is some electrolyte leaking out on some of these. It's a bit hard to see, obviously, because it's kind of tiny, but there is some signs of the magic fish goo. Okay, all the rest of these pads look good, so that just means we have to solder on the new capacitors. So, a lot of these to go through, so enjoy the fast-forwarded action. All right, so that is all 19 of those soldered. And now I'm going to use my meter to check and make sure that these aren't shorted. We're good. You good? You good? Check over here. Ain't no good. Yep. Yeah, right there. And check on the rotation first. Let's change. Right here. Okay, so that is the board. All done, all back together. You replaced 19, 20, 21 on this one, and then 6, 7, 8, 9, 10 on this one. Let me see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, 10 on that one, so now we just get it back together. And I put all this capacitor shrapnel in the trash. So let me do that and we'll be right back. Okay, popped a new battery in there, and now the installation is reverse of removal. So, fish everything in here. Trying to trap any cables. And I can't remember if I mentioned, but I replaced this battery. The previous one had 5 millivolts left, which is not sufficient, I'm going to say. So with the new battery, we should be able to actually save patches, which is, you know, pretty cool for a digital synth to be able to do. Of course, this is my last 2032 battery, so someone remind me to order some more. Just down in the comments, so I don't forget. And don't miss this one underneath the ribbon cable. And now, let's get those cables in there. For the keyboard matrix. For the display, I assume. And this is for the front panel. That should be fine. Now, I'm not going to put this in yet because I need this to go through the ferrite. So I am going to just install. Let me see. No, that was on top, right? So I'm going to install this one over here. That one comes from the jack board, so we don't install that yet. And I think I will install this now. Now we had to lift these tabs to remove the connectors, but when we go back to insert them, we can actually push that connector locking tab down, and then these just push in and they don't pull out. It's a one-way I should put that on the right side of the shielding, is what I should do. So don't make that mistake. You know what, instead of getting ahead of myself, I'm going to put the screws in. Let's do it that order instead. And we'll make sure this is lined up. Oh, hang on. I have one more of these screws. No, I have... Yes, one more of these screws. Where is that from? I need to take this panel back off. One of you in the comments has probably spotted it already. Go ahead and tell me I'm an idiot. I might have to go back and look over the footage. It's not from the jack board, because the jack board... Wait a minute. No. Ah, this comes from the grounding connector, doesn't it? Yeah. Crisis averted. So let me just count the other screws, make sure I have the right number. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7... Hang on. How many of these do I have? 1, 2, 3, 4, 5, 6, 7, 8. Now how did I lose one? What? Oh wait, there's just one hiding under here. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. I have the right number of screws. Let's do this again. Oh, come on. Don't be this way, screw. And again with the connector. Right. Just going to put all the screws in before I did the connectors, so I didn't screw it up again. You know, the hilarious thing is I've actually done that more than once. So when I was poking around here earlier, figuring out which capacitor I needed, yeah, I put this on the wrong side of the foil and had to pull it out. You think I learned? Nope. But now you can feel better about doing it yourself too, because Lord knows you probably will. Now, before I forget, so the next person knows when to change the capacitors. All right, so make sure all of these wires are straight. Make sure they feed in correctly. Sorry you can't see this. It's a little bit tight in here. Again, make sure all the wires are straight. Make sure they feed in correctly to each slot. And just to, I forgot to do this one. Again, someone in the comments probably saw that. Alright, then we have one more connector, which is on the jack board. So pin 1 has a stripe. It's a little bit hard to see sometimes, but it is there if you look for it. That just pushes in nicely. There we go. And oh, we need to straighten out some pins on this one. There we go. Latches down and make sure each of those goes in straight. Nice and secure. Okay, so I'm going to flip this over and make sure, wait, I'm going to connect the ground pins, ground cables. Getting ahead of myself. There we go. Now I'm going to flip this over, check the functionality, and I will be back in a minute. So do you remember how earlier in the video I was ominously foreshadowing that if you leave the capacitor goo on the motherboard for too long, it'll eat a hole in the PCB and destroy the part that is completely irreplaceable? yeah, you get an error kind of like that. So, since this board is irreplaceable, this entire synth is now junk and we will throw it in the trash. Or at least that would be what I'd say if I were a quitter, but I'm not, so let's try and fix it. Okay, the board is back out, and if you will recall, this 100 microfarad capacitor here was the main culprit of spewing crap all over the board, and I'll put a picture, a photo I took earlier of what that actually looked like when I started. I've obviously cleaned off that gunk now, but there are traces in this area that are somewhat corroded now, and in fact I did actually locate the one that is completely broken. Now let me see if I can zoom in here a little closer. This right here is obviously IC7, and if we look around pin 54 here, you can see it. We have a trace coming down here and into the danger zone. And this via right here goes to the other side, and it is heavily corroded. And I will try to put up another picture of that. But remember that the shmoo was sort of around in this area. There is, on these traces here, a little bit of corrosion. I tested those, and those seem to be okay, so I don't think we'll need to do anything there. But because there's no connection on this via, that's what is going to be causing our problem, I hope. So we're going to be repairing this, but sort of give you more context of what this via is doing, let's have a look at the schematic for a moment. All right, so this is part of the schematic here. We have IC 6, 7, 8, and 9, or these are the 4 DSPs here. So it was 6, 7, 8, and 9. And what we have is we have an address bus coming in, a data bus coming in and out, and then a series of, this is like a 6-bit bus that daisy chains between, like comes out here, in here, out here, in here, so between the 4 ICs. And then IC9 goes off to the DACs, which are on a different page of the schematics. There is also a RAM chip attached to IC6 and a larger RAM chip attached to IC9. Rather amusingly, they have a 16-bit 256K RAM chip over here, but they only actually use 8 bits of it. So they must have had a good deal on these ones or something, I don't know. I don't think these are wrong, anything wrong with these ones, because if we look here, so addresses are from pin 74 to, let me see, 88. And I think there's 1 or 2 skipped in between here from like grounds and V pluses. And then, let me peek in here a little bit. This is like super tiny writing, so you probably can't see it. I definitely can't in person. So the data is, let me double check that. Sorry, I misspoke earlier. I said 54. That should have been like a 94, I think. Go back here. The pin we care about is, let's see, that's 80, 85, 90, so 95. So that's 94, not 54. My bad. So pins 92 to 99 are for the data bus. And interestingly, this is actually the high 8 bits of the data bus. And then off the side of the schematic here, they actually connect to this corner of the CPU. And so I trace this out. The data bus connects okay to all 3 of these DSPs. So that's IC 7, 8, and 9. But IC 6, this one pin here, it goes from this chip to this chip. It does not connect on this side because of this dead via. So hopefully that explanation sort of made sense. So hopefully once we fix this via, then this CPU will be able to send commands to all 4 of these DSPs, and we won't have that error, which is manifesting as well as some of our voices missing. So, you know, if you don't have a DSP generating the voices, you're not going to be able to hear them. Now, I do not have a lot of hope of being able to solder this trace and also show you that, because I bought a microscope a while ago that does not have a camera attachment, and so I can't really show you what I'm looking at while I'm doing this. So I'm just going to fix this, and I'll take some photos for you, and we'll come back and see if it hopefully worked. All right, with a little 30 gauge magnet wire, I was able to bridge the broken via and put a little piece of wire there, soldered it down to the trace, and then up to pin 94 is just the regular trace. It was just fine. I did beep this out with my meter, and it has conductivity, so let's go get this board back in the synth and see what it looks like. Okay, the moment of truth. We hold down filter type 1224 dB and oscillator 2 sync at the same time, and we turn the power on, and we wait for it to say Roland JP-8000. Hey, I like the look of that. Oh, whoops, I pressed MIDI test. Anyway, it said okay. It totally said okay. So let me see. I'm going to hook up my speaker. Okay, we got the volume all the way up. We got the speaker connected. I'm going to turn the speaker up a little bit. Do I get sound right now? No, probably not. Okay, I'm going to press 8, which is the audio test. So if I go through this, all right, I hit this one. No. Crap, no, I hit right, don't I? Okay, got a triangle wave, that sounds good. Got a saw wave, that sounds good. Got a square wave, it sounds pretty square to me. We got effects, I assume that's what it's supposed to sound like. All 8 voices, oh thank goodness. That makes me happy. All right, I got a bunch of screws to put back into this thing, so I'm going to do that, and you don't need to see me screwing a screwdriver again. So I'll be right back, and we'll try to make this actually make musical sounds. All right, we are pretty much good. I do still have to clean the potentiometers and probably change the tack switches. I think, let me see, this one, oh no, that one's working, sort of. I'll probably stick that in a different video, or maybe I'll just do it and not show you because, yeah, it's just a lot of soldering. But hope you enjoyed that video, and I will see you on the next one.